So to move on to the last couple methods here, we did greatest common factor, we did trinomial and the two binomials. This next video is going to do grouping and difference of squares. Okay, now I said before we ended the last video that if you are good with trinomial and the two binomials, grouping should be fairly easy. Okay, what I want you to start thinking about is how many terms there are that we're dealing with. Okay, for grouping, okay, must be the term ax cubed plus bx squared plus cx plus d. Okay, it's important that these exponents are going down in order. Okay, we can't skip any exponents, and hopefully once we get into factoring completely, when we start taking out greatest common factors before we start doing the work, you should end with your constant here as well. Okay, 4 terms, and that's what we need to start picking out. How many terms are there? Now, the way you factor this is basically the same way that we did the trinomial and the two binomials, but we're going to start about halfway down. 4x cubed minus 12x squared plus x minus 3. Again, kind of ignore the equal 0 for right now. But what I'm going to do first is, we already have 4 terms. Just like in the trinomial and two binomials, once we had 4 terms, we grouped it. That's exactly what I'm going to do here. I'm going to group and take out the greatest common factor. These steps are going to be the same. 4x cubed minus 12x squared. Greatest common factor is 4x squared, which leaves us with a x minus 3. X minus 3 now, the only greatest common factor is a 1. I'm still going to put my 1 there to help me remember to bring it down. But that x minus 3 is not going to change. And we can see, just like before, okay, inside our parentheses, x minus 3, they are the same values. Okay? So when I set this up, we are going to have x minus 3, just like in the trinomial and the two binomials, and we're left with 4x squared and a positive 1. 4x squared plus 1. And you would look, can anything else be factored? In this case, we're going to be done. That would be our final answer. Okay? And again, if you multiply that through, it would work out and give us our original problem again. Okay? I'm going to say that's a good way to test your answer, but make sure you have time to do it. You don't want to spend too much time on a test checking every single answer. Okay? So that is grouping. Like I said, basically the same thing as trinomial and two binomials, but about halfway through. It's a little less work. Okay? And I'm going to go right into our last method, which is difference of two squares. Okay? We're going to be looking at perfect squares in this problem. Okay? The problem has to be in the form of a squared minus b squared. And this is what you're going to need to identify. What is your a, what is your b? And we're going to be just writing it out in the formula, a minus b, a plus b. Okay? So this is what our problem is going to look like. This is what our answer is going to look like. Now there's 2 rules. It must be subtraction, okay? A squared minus b squared. And they have to be perfect squares. So you do need to know your perfect squares. The better you are at your perfect squares, okay, the easier this is going to be. So remember, you're just going to be taking numbers, multiplying by itself. That's what a perfect square is. 4, 9, 16. Okay? Anything that has a perfect square root or a nice square root where you're not left with decimals. So the example we have here is x squared minus 25. It's subtraction. And these are both perfect squares. You can take the square root of both of those. If you take the square root of x squared, that gives you x. The square root of 25, not minus 25 or negative 25, just the 25, and you get 5. And this ends up being what we just did there. Since they both work out, the first term is our a, and the second term is our b. So there's our a and b to plug into that formula. You're just taking the square root of both of those. Okay, we'll talk more about how this cancels out later, the square root of x squared into x. But this is just showing that they're both perfect squares. It identifies our a and b. And now we just need to plug in our answer then, x minus 5, that's our a minus b, x plus 5. And there's our factored form. And again, if you multiply through distributive property, you would end up with x squared minus 25. Just be careful when you have a leading coefficient. That also has to be the perfect square. So if we're looking at this one, Okay, it's subtraction, so we're good. It follows that rule of subtraction. Square root of 4x squared. Now be careful, make sure you square root both of these. Square root of 4 is 2. Square root of x squared is x. So our a is going to be 2x. Square root of 49, again, it's just the 49, not the minus. Square root of 49 is 7. And again, there is our a. And there's our b. So now we can take it, plug it into our final answer. 2x minus 7, 2x plus 7. And there's factoring using the method of difference of two squares. You are starting with two terms. Okay, so again, start thinking about how many terms are in the problem, and that's going to be key what method you're going to use. Next, we're going to start factoring completely and also using factoring to solve for the value of x.